Hi children, welcome to Veena's chemistry class. I am Veena, I am a science teacher. Today I am here to discuss a topic from chemistry, that is class 10 NCERT science book topic, that is chapter 1, chemical reactions and equations. Before we begin our session, I just want to ask a question. It's a quiz question. Please comment your answers in the chat box, okay? Which metal can exist in the liquid state at room temperature? Okay, please comment your answers in the chat box. Now, let's come back to our topic. We are going to discuss how to balance a chemical equation. So when we talk about balancing chemical equation, I have a simple question. What is a chemical equation? What is its importance? Why should we balance it? Why should we balance it? So first of all, let's see what is a chemical equation. A chemical equation represents a chemical change called a chemical reaction. We can see a number of chemical reactions in our daily life. A lot of chemical reactions are happening inside us and in our surroundings, not only in the chemistry lab. Okay, so let's begin it with a simple example that you have learned in class 8. Do you remember the lesson metals and nonmetals? When you learnt about the properties of metals, you have learned about burning reaction of magnesium ribbon. That is, magnesium ribbon burns in air with a dazzling white flame to produce a white ash, a white powder called magnesium oxide. Describing a chemical reaction in the form of a sentence is quite long. We can find some easiest way to represent a chemical reaction. That is, the simplest way is to represent it in the form of an equation, a chemical equation. That is why we are using chemical equations. Equations help us to represent a chemical reaction in a simple way. And that is quite useful. Okay? So look, in a chemical reaction, we will show how the reactants are transforming into products. So reactants, they are the substances that undergo changes. And products are the new substances formed when the reactants undergo change. So let's see. In the case of magnesium ribbon, identify the reactants. Magnesium is burning. When magnesium is burning, magnesium is one reactant, but it is reacting with an invisible reactant in air. That is why we will say magnesium is burning in air. That means in every combustion reaction, there is a silent reactant, that is our oxygen gas. So there are two reactants. So let us write the name of two reactants here. Magnesium is the first reactant, and then comes our oxygen gas. There are two reactants, but there is a problem. When you write it in the form of an equation, you need to put a plus sign between the reactants if there are more than one reactant. Okay? So we put a plus sign here. Now we need to put an arrow. This arrow shows that the reactants are changing into products. This arrow represents the direction in which the reaction is proceeding, or we can say it shows the formation of products. So what is a product formed here? When magnesium reacts with oxygen, we will get magnesium oxide. Now we can say the reactants are on the left hand side of the equation and the products are on the right hand side of the equation. So these are the reactants and this is a product. But again, this is a word equation. A word equation clearly shows how the reactants are transforming into products. But there is again a more concise and useful way of representing a chemical reaction. That is, representing this equation using symbols and chemical formulas. That is more useful. So let us see. But here we need to understand how to write the symbols of the elements and compounds. That is very important. That is a main thing. Whenever you are writing a chemical equation, you need to know how to write the chemical formulas easily or correctly. For that, you need to remember the valency of the elements, the symbols of elements, how to write the symbols correctly. Now here, magnesium is a metal, oxygen is a non-metal. Magnesium oxide is a compound. So these two are elements. Now, magnesium. How will you write the formula or the symbol of magnesium? Magnesium is a metal. The symbol of magnesium is Mg. M is capital letter and G is small letter. Now comes oxygen gas. You know, in the case of metals, it is very easy to write their symbol because metals are generally considered as monoatomic. The atoms of the metals are held together by strong metallic bonds. So we can consider them as monoatomic. In the case of monoatomic molecules, we need to put only their symbol. So this represents one atom of magnesium or 1 mole of magnesium. Now in the case of oxygen, oxygen is a non-metal, it is a gas. But there is one problem. The atoms of oxygen, they do not have independent existence. They cannot exist as a single atom. Okay, 2 atoms of oxygen always combine together to form a molecule. A molecule is formed when 2 or more atoms combine with each other chemically. Okay, so oxygen is a diatomic molecule. Molecule has independent existence, but some nonmetals, they do not have independent existence. So they prefer to exist in the form of molecules. So oxygen is diatomic. So that means 2 atoms of oxygen combine together to form oxygen molecule. So when you write the formula or the symbol of oxygen, you need to write it like this. 2 atoms of oxygen combine to form the molecule. So you need to write it as O2. 2 is a subscript. There are other gases in the air like nitrogen gas. Nitrogen gas, the atoms of nitrogen also, they don't have independent existence. For a nitrogen, we will write it as N2. Then hydrogen gas, the simplest gas, hydrogen is also like that. It is diatomic, H2. If it is chlorine gas, we will write it as Cl2. So, whenever you write a chemical equation, remember when we write the symbols of these elements, remember these elements exist as diatomic molecules and you need to write their formula this way, N2, H2, Cl2, etc. Okay? Now comes magnesium oxide. Here it is made up of 2 elements. So, magnesium and oxygen. So, this oxide is the anionic part. That is why it ends in IDE. IDE. See, only 2 elements are there, magnesium and oxygen. Okay? So, how will you write the formula? That is why I told you, you need to remember the valency of the elements. Okay? So, I will show you how to write the formula of magnesium oxide. So let's see. First you write the symbol of the element, magnesium, and then oxygen. This is the symbol of oxygen. Now you need to write the valency of magnesium and oxygen. You know, in the case of magnesium, the atomic number of magnesium is 12. Then we need to write the electronic configuration of magnesium. So atomic number of magnesium is 12. The electronic configuration is 2, 8, 2. 2 electrons in the K shell, 8 electrons in the L shell, and 2 electrons in the M shell. And do you remember the octet rule? All atoms which are not stable, which do not have an octet configuration, try to gain or lose or share their electrons in order to achieve the stable octet configuration of the nearest noble gas. So in the case of magnesium, magnesium will lose 2 electrons. It will lose 2 electrons to gain the octet configuration. So the valency of magnesium is 2. Now in the case of oxygen, what is the atomic number of oxygen? It is 8. What is its electronic configuration? There are 2 electrons in the K shell and there are 6 electrons in the L shell. Now, already 6 electrons are there in the L shell. It needs 2 more electrons to complete its octet. So, it gains 2 electrons when it combines with other elements. So, oxygen needs 2 more electrons. So, the valency of oxygen is 2. Now, since both of them have the same valency, we can give the simplest ratio, that is 2:2. The simplest ratio is 1:1. Now, crossover. One magnesium and 1 oxygen. The formula will be Mg. Children of class 10, they always have a doubt regarding this part, how to write the chemical formulas correctly. So whenever you have a confusion regarding this, children, you please remember their valencies. But it is very important to remember their atomic number. Okay, atomic number, electronic configuration, and then you can make up their valency. Fine? Now, about this balancing part. Why do we need to balance a chemical equation? Just count the number of atoms of each element on the left hand side as well as the right hand side. Look, how many magnesium atoms are there? 1. How many oxygen atoms are there on the reactant sides? 2. Now come to the product side. Here we have 1 magnesium and 1 oxygen atom. The number of magnesium atom is same on the reactant side as well as on the product side. But what about the number of reactants of or the number of atoms of oxygen atom? Here it is 2, here it is 1. That means it is not balanced. It is an unbalanced equation. This equation is unbalanced. Such equations are known as skeletal chemical equations. So this is a skeletal chemical equation representing burning of magnesium ribbon. So why do we need to balance it? Recall law of conservation of mass that you have learned in class 9 by Antoine Lavoisier. You know, Antoine Lavoisier is considered as the father of chemistry. So he conducted a lot of experiments and then he came to know that the mass of reactants before the reaction and the mass of products after the reaction, it remains same. Sometimes the products formed will be in the gaseous state. But if you are conducting the experiment in a closed situation, in a closed container, we can see that the mass of the reactants and the mass of the products formed will be same. What does it mean? In ordinary chemical reactions, mass is neither created nor destroyed. So there is nothing, no change happening to the mass of reactants and products. Here the reactants are simply transforming to products. Okay, so the number of atoms of each element will be same before and after the chemical reaction. So it is very important to balance a chemical reaction. Now you understand? Okay? While we are doing stoichiometric calculations and other calculations involving chemical equations, it is very important that we are doing it for balanced chemical equations. And not only that, we need to show the physical states of the reactants as well as products in the reaction. Not only that, it will also show you the physical states and the reaction conditions like temperature, pressure, etc. So now let's see how we can balance it. Look, here the number of magnesium atoms are same, but the number of oxygen atoms are not same. On the right hand side, that is on the product side, there is only one oxygen atom. Here there are two. So what to do? Multiply this by 2. Then we need to put this 2 here. Oxygen is present in this compound. Look, 2. Remember, we cannot put 2 here. It is wrong. Okay? We cannot change the formula of the compound. You have to put the 2 in front of this compound. Now, there is another problem. Now the number of oxygen atoms are balanced. But when you put 2 here, this is applicable to all the elements present in the compound. Here, now there are 2 magnesium atoms. When you multiply this with the 2 here, now magnesium is also 2 number of atoms. Now we can balance it here. If there are 2 magnesium atoms, we need 2 magnesium atoms on the reactant side. What to do? Just multiply the number of magnesium atoms by 2 and put this 2 here in front of magnesium. Now see, let's count. There are 2 magnesium here and here, 2 oxygen atoms, here also 2 and here also 2 oxygen atoms. Okay, the equation is balanced. Now you can also show the physical states. Physical states can be represented in the form of some there are some letters that can show the short form. For example, if the reactant is in the solid state, you can write like this. Put a small bracket and put S, small letter S for solid. This is for solids. Now, for reactants or products in the liquid state, you can put the small letter L in the brackets. This is for liquids. Now there is one more state, that is gas. Okay, gaseous state. Very easy, put G. Now one more thing. There are certain reactants which are found in the dissolved state. That means, for example, you are taking sodium chloride solution or some salt solution. What we do is we dissolve that salt in water. If you dissolve a salt or acid in water or a base in water, we call it aqueous solution. So if usually reactions are conducted in the solution phase. Okay. So we call such solutions aqueous solutions. If the solvent is water, we call such solutions aqueous solutions. So for aqueous solution, the short form is AQ. Remember this while writing the physical states. Now see, why don't we write the physical states here? Magnesium is a metal, and you know metals are in solid state. Now oxygen is a gas present in air, so it is a gas. Magnesium oxide, it is a white powder, it is a solid, so the physical state is solid. Okay children, So I hope this part is clear for you. Now I will give you another one as a homework for you. You just try. Hydrogen plus chlorine giving hydrogen chloride. Take care, these two are elements, non-metals, hydrogen and chlorine. They are diatomic molecules, so how will you represent it? Then hydrogen chloride is a compound. So how will you write the formula of hydrogen chloride? Please do it. Okay children, so see you, bye bye. If you like this video, please like it and subscribe for the upcoming videos. Bye. Hi children, welcome to chemistry class today. I am Veena. Today we are going to discuss about balancing chemical equations. We have already seen one video. In this video we are going to discuss more examples how to balance chemical equations. Okay, so let us start with this chemical equation. Here this chemical equation is already represented using symbols and formulas. Here this symbol Fe plus H2O giving Fe3O4 plus H2. So this is iron and this reactant is water. Water is the reactant, okay? Then Fe3O4, this is iron oxide and hydrogen gas. Okay, so you will learn about this equation in the chapter metals and non-metals. Okay, that is iron is a metal and we are actually, iron is reacting with the steam. Here water is in the form of steam. This is a reaction of metal with water. Okay, now we can begin with balancing it. The first step is to count the number of atoms on the left hand side, that is on the reactant side, and on the right hand side. Start. Now this is left hand side children and this is right hand side. We can begin with iron. How many iron atoms are here? Only one. Now how many iron atoms are there on the product side? 3 are there. Now comes hydrogen. Hydrogen H2, that means 2 are there. Here on this side, hydrogen, there are 2 atoms. They are already balanced. Now comes the next element, that is oxygen. Only 1 atom is here. Here there are 4 atoms of oxygen. So have a look at this. Compare the number. Now we can see there are 4 atoms of oxygen and here hydrogen atoms are balanced but iron and oxygen atoms are not balanced. Well, we have a confusion with which element we should start, iron or oxygen. For the sake of convenience, you would choose the element that contains maximum number of atoms. So from here we can see that oxygen contains maximum number of atoms, that is 4. Why don't we begin with here? Okay, so here 4 are there, here only 1. So on the reactant side, in order to balance it, we can multiply the number of oxygen atoms by 4. Now where will you put this 4? We will put this 4 here in front of H2O. But I told you, when you put the number here, this number is applicable to both hydrogen and oxygen. That means now the number of hydrogen is also increased. So 4 2's, there are 2 hydrogen atoms, 4 2's is equal to 8. Now there are 8 hydrogen atoms. What about here? Only 2 hydrogen atoms are there. So in order to balance, you can multiply this side also using 4. So that you will get 8 hydrogen atoms. Let's see, where will you put the 4? Here. Please do not try to change the formula of the substances. Okay. So it is always safe. You put them in the box. Look. So before you begin to balance, you can put the elements, the reactants and products in boxes so that you will not change the formula of the compounds and the elements. Okay? You need to do the balancing here. Write it as a coefficient. Now, hydrogen is also balanced. Now what about iron? Here 3 are there, here only 1. So multiply this side by 3. Okay? So you can write the balanced chemical equation 3Fe plus 4H2O giving Fe3O4 plus 4H2. Now I told you we need to write the physical states as well. Okay? So if you know, sometimes in balancing chemical equations physical states are not asked. But it is always better you know the physical states. Okay, I told you this is a reaction of metal with steam. So here iron reacts with the water in the form of steam. So here water is in the form of steam. Okay, iron is a metal, so it is a solid. Now water is in the form of a gas. Iron is reacting with the water vapor, so it is a gas. Now comes Fe3O4, iron oxide. This is a solid. Oxides of iron are always solids. Okay, so this is a solid. Now what about hydrogen? Hydrogen gas is released when a metal reacts with water. So this is a gas. Now our equation is perfect. It is balanced. Let us discuss another one. There's the third one. This is a statement. Hydrogen gas combines with the nitrogen to form ammonia. You know both the hydrogen and nitrogen are in liquefiation states. And it forms ammonia. So how will you translate this sentence into the form of an equation? Why don't we write the word equation first? So look here. When you get a sentence like this, a statement like this, first you need to identify which are the reactants and which are the products found. Okay, so from here can you make out which is the product and which are the reactants? Hydrogen gas combines with nitrogen to form ammonia. So what is formed here? Ammonia. So ammonia is the product and hydrogen and nitrogen, they are the reactants. So hydrogen plus nitrogen to give ammonia. Okay? Elements, these are non-metals. Hydrogen and nitrogen, these are the gases present in air. Okay, we can also combine them in the lab. Now my question is, how will I write the symbol? Hydrogen and nitrogen, they are diatomic molecules. Okay, so when you write hydrogen, the symbol of hydrogen is this, H2 plus nitrogen is also a diatomic molecule. We will write it as N2. Gives ammonia. Ammonia, you may not be familiar. This is the formula of ammonia. Both are non-metals. Okay, NH3. Now, shall we start? Start counting the number of atoms on the reactant as well as on the product side. Hydrogen, here 2 are there. Here 3 hydrogen atoms are there. Here nitrogen 2 are there. Here only 1 nitrogen. Okay. So what is the rule? It is convenient to begin balancing with the number of atoms of the element which contain maximum number of atoms. Here hydrogen has more number of atoms. So we can begin with the hydrogen. There is a problem. This is not an easy number. Here 2 are there. Here 3 are there. This is an odd number. This is an even number. How can we equalize them? A very easy way is to multiply. Okay. On this side you multiply by 2, okay, and on this side you multiply by the number 3. So here you multiply it by 3, you will get 6. On this side you multiply it with the 2, you will get 6. So put this 2 here, and here you put this 3. Now look, the number of hydrogen atoms are balanced. Here 2 3s are 6, 3 2s are 6. Now when you put 2 in front of a compound, remember this is a coefficient, and this coefficient is applicable to all the elements present in that compound. Here 2 3s are 6, but what about nitrogen? Now there are 2 nitrogen atoms. Okay, so this 2 is applicable to nitrogen also, there are 2 nitrogen atoms. Now look here. Nitrogen is also balanced, there is no need to put anything here. Here 2 are there, automatically when you put 2 here, now the sides are balanced. The number of atoms of nitrogen on the reactant as well as on the product side are equal. So equation is balanced. Now welcome back children. There is another word equation. You need to translate it into a chemical equation in the form of using symbols and formulas. Okay. Barium chloride plus potassium sulfate gives barium sulfate plus potassium chloride. This is an example for double displacement reaction. You know, in double displacement reactions, the radicals, there will be an exchange of the radicals between the reactants. Okay, here look here, barium chloride. Barium, it exchanges the chloride ion with potassium, see? And potassium exchanges the sulfate ion with barium. Now you will get the products, barium sulfate and potassium chloride. Okay. So this is an example for a precipitation reaction also, because barium sulfate is an insoluble solid formed in this reaction. Now our question is how to balance it. First we need to identify or find out the chemical formula of these compounds. Barium is a metal. Chlorine is a non-metal. Potassium is a metal. Sulfate is a polyatomic ion. So you have learned about polyatomic ions and their examples in class 9. Please recall it. Now, barium is a group 2 metal. Its symbol is Ba. Now the next question is, what is the valence of barium? I told you barium belongs to group 2. The same group in which you will find beryllium, magnesium, calcium, etc. So barium belongs to this group, second group, okay, that is beryllium, magnesium, calcium, strontium, barium, okay, strontium, fine. So this is group 2. All these elements have +2 oxidation state, or their valency is 2. All these elements lose 2 electrons to attain octet configuration, which is similar to the nearest noble gas. Beryllium will lose 2 electrons and it will attain the duplet configuration of helium. These elements, they will gain octet configuration. Okay, so the valence of all these elements is 2. So whenever you think of barium, the valence is 2. Sometimes it may be difficult to remember, but think beryllium, magnesium, calcium, strontium and barium, they belong to group 2 and their valence is 2. Now about chloride. So whenever the name of a compound ends in ID, remember it is a binary compound, only 2 elements are involved here. Here when it ends in IDE, that means only chlorine is present there. My question is, what is the valency of chlorine? For that you need to remember the atomic number of chlorine and its electronic configuration. So in the case of chlorine, you know, the atomic number is 17. How will you write its electronic configuration? 2 electrons in the K shell, 8 electrons in the L shell, only 8 electrons can be accommodated in the H shell, and 7 electrons in the M shell. Now already 7 electrons are there for chlorine. How will it achieve the octet configuration? By losing 7 or by gaining 1? Chlorine has a tendency to gain electrons. So it will accept 1 electron from any other element to complete its octet because it needs only 1 electron. So what will be the valency of chlorine? 1. Now we shall see how will you write the formula of barium chloride. Barium, the valency is 2 because it belongs to group 2, and chlorine, its valency is 1. Fine. Crossover. Now there is 1 barium and there are 2 chlorine atoms, Cl2. Okay? So we get the formula of the first compound, BaCl2. Now the next one is potassium sulfate. Potassium belongs to group 1. So all the elements in group 1 have a valency of 1. Okay, so which are the elements in group 1? Do you remember? For example, sodium, lithium, sodium, potassium, rubidium, cesium, all these elements, they have 1 electron in their valence shell. So they will lose 1 electron to gain the nearest noble gas configuration. Okay? They will lose 1 electron, so their valency is 1. Now, what is the symbol for potassium? Is it P? No. The symbol of potassium is K. K carrier. Remember it. K. The symbol of potassium is K. Now, next is sulfate. Remember it ends in ATE. That means it is a polyatomic ion. Do you recall? Please recall the formula of sulfate ion, that is SO4. And you should also remember the charge of sulfate ion, that is 2-. But while writing the formula of sulfate ion, while writing the formula of compounds using with the sulfate, you don't have to put the charge here. Okay, the charge is needed in order to write its formula. So when you want to write the formula, either you write the valency or the charge. Here the charge is -2. Now potassium belongs to first group element, so its valency is 1. Crossover, you don't have to put the charge in the formula. Okay, so 2K. K2. Now there is only one SO4. SO4. This is the formula of potassium sulfate. Now let's come back to our product side. I hope there is not much discussion required there. Barium sulfate. Okay. So once again, barium belongs to group 2, so its valency is 2. Sulfate, you know the formula. Now the charge of sulfate is 2. 2:2. The simplest ratio of 2:2 is 1:1. So the formula will be there is only 1 barium and 1 sulfate ion. This is barium sulfate. Remember, in barium sulfate, this oxygen is, you cannot write it in small letter because it is oxygen. The symbol of oxygen is capital O. Now, our next product, that is potassium chloride. Potassium, the symbol is K. Chlorine, the symbol is Cl. Capital C and small letter L. Sometimes children will write it like this, but it is wrong. It should be small letter. Potassium group 1 element, valency 1. Chlorine, Group 17 element, its valency is 1 because it needs one more electron to complete the object. KCl. Okay. Now we can start counting. Left hand side, right hand side. We can start with the barium. On the reactant side, there is only one barium. On the product side also, there is only one barium. Now chlorine, there are 2. Here, how many chlorine is there? Only 1. Now, potassium, here 2. Here, only 1 potassium is there. Now, the next is sulfate part. Children, there is an easy way to do this. Instead of counting how many sulfur and oxygen atoms are there, you can take it as a single unit. And this is possible only if sulfate radical is present on the left hand side and the right hand side of the equation. Okay? If a polyatomic ion is present on the left hand side as well as on the right hand side of the equation, then you can take them as a single unit. So, write it as sulfate. How many sulfate radicals are there? Only 1. Now here also only 1 is there. Fine. Here the number of sulfate ions are balanced. Barium ions are balanced. But chlorine and potassium ions are not balanced. Okay, both chlorine and potassium have 2 atoms here, but only 1 atom here. So, we can take potassium, multiply it with the 2. Okay, where will you put that 2? Here, in front of potassium chloride, 2. Now, the number of potassium ion is balanced. This 2 is applicable to chlorine also. It is balanced. Okay, now see, equation is balanced. So, practice more questions, children. We will see in the next video. Bye-bye.